So I increased the ambient light to 1300 lux, which is quite a lot. And as we can clearly see here now, we've been using the similar settings because, I mean, as of ease of use perspective, you don't want to modify the camera settings for every time the lighting changes. So by reusing the same settings, we can see that here we have the results are quite different. From the 2D point of view, you can see that we're overexposed, like the red color is not as red, and the same with the yellow. And if we go into the 3D data as well, we can also clearly see that now we're starting to lose data. So on this black reflective parcel, we only see half of it. On this white letter or mail, we lose some data. It's overexposed, and the same goes with the highlights and the more reflective areas on this plastic bag as well. So we can clearly see that the quality of the 3D data, when we change the ambient light, it drastically decreases. And yeah, if we zoom into this box, I mean, even though you were able to segment the box within using the 2D image, it will be quite challenging to pick this box because you don't have any pickable surface. At best case, you would, with your vacuum gripper, you would pick somewhere on the side, but it's still risky because the box may dangle, you may drop it while you move it, and so it's definitely not an ideal situation for the robot cell. Okay, so with the second camera here that we're looking at, what happens when we increase the ambient light with changing the environment. So again, this is with 1300 lux, quite a lot, and we can clearly see that with the same settings, the 2D image is overexposed. So we have, when it comes to this white letter line on the top, we can clearly see that it's completely completely white out basically, and we have highlights on and reflections coming back to the camera. So the 2D is clearly affected. So let's see how it looks when it comes to the 3D data. For the 3D data here, we can also clearly see that the quality of the point cloud has been affected by the increase of this ambient light. What's very noticeable is this the holes that we get in the data because it's overexposed, and if we remove the color again, we can clearly see that the camera is doing some hole filling, but it's not very accurate hole filling, I would say. And when we look at some other objects, again, we go back to these two ledges on top of each other, it's even more noisy now. So there's no way you'll be able to clearly separate one of the letters from the other. And I think that cover goes across the entire scene. With stronger ambient lights, we see that we introduce more noise, and the camera is not able to accurately represent the true surface of, I would say, almost any of these objects. So like the boxes here, they don't have sharp edges at all. They're all smoothed into each other. The nice thing, I would say, we should give them some kudos as well, is that at least they're able to get data on all the types of different objects that we see here. that's pretty nice. But there's, I mean, with the human eye, we barely able to separate these objects from each other. So I find it challenging for a machine learning algorithm to do it. Okay, so let's move on to the Zivid camera again and see how well that performs under a complete different type of ambient light. So yeah, with 1300 lux, quite strong. If we do a capture, we can see that in the 3D data there's no changes. There's no difference. We have equal amount of kind of high quality point cloud, which is really cool. If we look at the 2D image as well, we can see that overall the entire kind of image is a bit brighter, but it's when it comes to kind of this big change in ambient light, the colors are very consistent. And that's kind of the key thing here, is that we're using the same settings. We haven't modified it at all. We're just pressing the capture button, and we're generating the same kind of high quality 2D and 3D data independent of the ambient light level. And yeah, if we zoom in again on some of this, we can see that we still have good coverage over everything. I think it's worth noting that where the other camera, the previous camera, had some highlights and it failed to generate the 3D data, so it did the whole filling. We can see that even though we know that these parts or these items are reflective and they have these highlights, there's no weird kind of hole filling doing something weird here. Like, we have perfect data on all of the objects. If we again want to inspect some of these edges, we can see that they're equally sharp as they were with the kind of normal ambient light conditions, which was 250 lux. Yeah, as we also could see that the previous camera wasn't capable of kind of detecting this small Zivid letter, where with the Zivid camera we are clearly able to kind of distinguish that from the cardboard box underneath.